Okay, these are the notes on using the Pythagorean theorem to find the distance between 2 points. So, on a coordinate plane, when the distance is horizontal, it's super easy. We can just count. We make our little whoop-de-whoops. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So the distance for this is 14 units. Same thing when it's vertical. We count 1, 2, 3, 4, 5, 6, 7, 8, 9 to count the units. So horizontal and vertical distances on the coordinate plane are super easy. But what if it's diagonal? If it's diagonal, you can't count those kind of lines because it doesn't work quite the same way. So if I have a point that looks like this, and we'll pretend that that line's straight. If you'll notice, I can't count squares because this isn't a whole square right here, and this is even less. And that's almost one, but not quite. And then there's just this little corner, so I can't count squares. But what I can do is make a right triangle. So here's my right triangle. So now that I have a right triangle, I can count those sides. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And now I can use the Pythagorean theorem to find my hypotenuse. So if this is C, because it's right across from the right angle, and this is A, and this is B, then, excuse me, I can use the Pythagorean theorem, A squared plus B squared equals C squared, to solve for my hypotenuse, or the diagonal side of that triangle. So that is 6 squared plus, actually I did that wrong. Let's use the numbers right. 11 squared plus 6 squared equals C squared. That's 121 plus 36 is C squared. 157 is C squared. Now remember that to find C, which is what I'm looking for, I have to take the square root of both sides, because those are opposite operations. And the square root of 157, rounded to the nearest tenth, is 12.5. Now that's approximate because it is rounded. But that's how I can use the Pythagorean theorem to find distance between points. Remember that we use distance is a lowercase d, so our distance is 12.5 units, which makes sense. Remember, the hypotenuse is the longest side. Our two other sides were 6, so it has to be longer than 6 and longer than 11. All right. So now let's do a couple more examples. So first we need to graph the point. So remembering how we did those, like starting in 6th grade, so it's been a while. We're going to graph -3. So this is the x and the y, and the x2, y2. Those are ones. So we go left or right first, and then up or down. And the signs depend on that. So -3 is 1, 2, 3. Up 5, 1, 2, 3, 4, 5. Here's the point, -3, 5. And the other one, 4, that's right and up. 1, 2, 3, 4, 1, 2, 3. This is the point, 4, 3. So here is my diagonal. And again, it makes it really difficult to count without full squares. But what I can say is that this is 2, and this is 1, 2, 3, 4, 5, 6, 7 is 7. So now I have A, B, and C. So I can say A squared plus B squared equals C squared. 2 squared plus 7 squared is C squared. That's 4 plus 49. 53 equals C squared. And then we're going to take the square root of both sides so that I get that C, which equals the distance, is 7.3. And I'm going to make that approximate. So an approximate is little squiggly lines instead of an equal symbol. So each time that we do this, we graph the points, and then we draw a right triangle to use the Pythagorean theorem. So starting at our origin, where our y and x axes intersect, we count 3 to the left, and this time, so we're going left and down. 1, 2, 3, 4. This is the point, -3, -4. And then this just stays and then goes up 4. 1, 2, 3, 4. So there is my diagonal. It doesn't matter which way I make my triangle. I'm going to make it like this time, just as long as I make a right angle. So this is 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8. Excuse me again. So we can say, and we're going to use D now because we are looking for the distance. So we're going to change that to a D, where this is still A and B. So D squared equals 3 squared plus 8 squared. D squared is 9 plus 64. D squared is 73. So D is the square root of 73, which is 8.544, and it keeps going. That means that D is approximately 8.5 units. Now remember, let's look back here a little bit. Remember that we changed this to D from C because while it is the hypotenuse and it is the C in the Pythagorean theorem, what I'm using it for is to find the distance. So that's why we can change those two things. Let's do it again. Graphing 1, 4, and 4, -1. You can hear my dog snoring. That's 3, 1, 2, 3, 4, 5. And there is D. So D squared equals 5 squared plus 3 squared. D squared is 25 plus 9. D squared is 34. So D is the square root of 34, which is 5.83 continued, which means D is approximately 5.8 units. Now remember, when we round, this is the 10th. The 3 makes the 8 stay the same. So we stay and go up 4. Starting at the origin, y and x, go up 4. And then we're going to go negative 5, 5, 1, 2, 3, 4, 5. So there is our diagonal. Now we're going to make a triangle. Again, it won't matter whether I make a triangle that way or this way, because it should be the same horizontal and vertical distances. So that part doesn't matter. So here's D. Oops. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5. So D squared is 9 squared plus 5 squared. D squared is 81 plus 25. D squared equals 106. So D is the square root of 106, which is 10.295. Keeps going. Now look here. This is the number I want. What does the 9 make the 2 do? I need a number in this place, so the 9 either makes it stay the same or makes it go up. In this case, D is approximately 10.3 because that rounds units. Starting at the origin, 5 right, 5 down. 5 right, 2 up. I don't need to do a triangle. That's our vertical distance. I can just count. So from intersection to intersection, 1, 2, 3, 4, 5, 6, 7. D, let me put the other side. D equals 7 units. What do you notice about these coordinates? They both have 5s in them, and they both have 5s in the x coordinate. So that means that we went over 5 both times. When the x coordinate is the same, that's a vertical line. Now let's look at number 6, the last example. We're going to go -1, -4, and over 3, down 4. So left, down 4, right, down 4. Again, notice that my y coordinate this time is the same. And if you look at the line that we draw when we connect our two coordinates, now we have a horizontal line. So 1, 2, 3, 4 whoop-de-whoops. Our distance is 4 units. So from this, what you should get is that when you have vertical and horizontal lines, I can simply count. So the 2 first examples and the last 2 examples, you can just count. You also can see that when I have the same y-coordinate, I get a horizontal line. And when I have the same x-coordinate, I get a vertical line. If I end up with non-vertical or horizontal coordinates, so diagonal lines, then we just make a right triangle, and I use the Pythagorean theorem to find the length of that missing side, because I can count the other 2.